Good night, everybody. Welcome to the first episode of Bar Arduino Worldwide. I'm Massimo Banzi, and this is...
Benedetta.
Thank you very much, Benedetta, for being with us again. And so the two of us are the hosts of this mini show, which interviews interesting people who do great projects with Arduino. And so, Benedetta, you were a guest, quote unquote, as well last time.
A couple of times. On the Italian one, too.
Yeah. So we are turning you into a huge star. So what happened this week?
Let's see. I've done a lot of baking because, like everybody else, I started growing my own sourdough starter. So lots of failed baking experiments. And then on a more professional level, I had a really nice, the first meeting of a lot of scholars at NYU, which is where I am faculty, about basically all the scholars that are working on research that's related to disasters or disaster adjacent. And it's funny because it's actually something that we had booked a long time ago for now. And so it was a really interesting conversation across all sorts of different applications of technologies for humanitarian purposes and other man-made or climate-made problems. So
Yeah.
very fitting with
Yeah, and also these are the kind of projects that you like to get involved. So it's
so it was really nice to see that there's a lot of other people working on interesting stuff. So
very nice. Thank you. Yeah, I mean, from my point of view, apart from my job, which is to attend conference calls in mute, my second job, I try to build some projects too as well. So this week I've been battling with an oxygen blood oxygen sensor that doesn't want to work. That now probably is working, and so I'm reminded by the fact that every project that starts off as a 5 minutes, I'm done. It always takes several hours. So, but that's our life.
Those are tricky, though.
Yeah, I know.
I feel like I never got one just like up and running in 3 seconds ever.
No, it's like this is going to be slam dunk, and then an hour debugging why the
confidence.
Shit. Okay. So let's talk about our guests tonight. I'm just going to quickly talk about them. And so we have Valentina Chinnici, which Benedetta is going to interview, who works at Arduino. And actually, since she's the Arduino guest, I'm going to also bring her in. Valentina, say hi.
Hello, everybody.
Yeah.
Hi, Benedetta. Hi, Massimo.
Hi, Vale. And so she's going to, Benedetta is going to interview her, so I'm not going to interfere. The second guest is Dominic Pajak, who also works at Arduino, but he's going to talk about retrocomputing and also tiny machine learning, which is pretty amazing. And the third guest, who will be interviewed by Benedetta as well, is Pascal Roobrouck, who comes from Belgium, and is going to talk to us about a few projects he's built with Arduino. So I will basically remove myself and leave you ladies to talk.
Bye.
Bye.
Bye, Massimo. Hi, Valentina. So
hi, Benedetta.
You. And it's so great, this woman-to-woman interview. I'm really appreciating this. So Valentina is the product manager at Arduino and is here to talk to us, I get, a little bit about the tension between tech and humanities and introduce her work. I'm a huge fan of what you do.
Thank you.
So I have some questions for you, but I'll let you first introduce yourself.
So I'm Valentina Chinnici and I'm product manager at Arduino. I've been studying for my whole life education and ed tech mostly. So for me, it's really important to find the conjunction between technologies and humanities, which is something that most people don't tend to either understand because they think that technology comes first whenever you're speaking about technologies. But then they forget about the pedagogical educational side of it, which is a loss either for the students or the teacher who teaches the topic. So I think that the most successful sessions and lessons that you can learn are a combination of factors that don't require necessarily to have a piece of hardware or whatever technology you're using, an app. It's just the technology is some kind of secondary help that helps you understand better, but it's not necessarily the only way that you can learn. So I try in my little world to bring this kind of notion with me, since I have a background in humanities. I studied education. I've been working with academic stuff in the past. I will discuss about it in my presentation. So for me, it's very important to bring this human factor within technologies.
Great. So good to hear that.
Oh, thank you. And so do you mind if I start with my presentation? And then if you have any question or other questions, we can get started. So let me go on. Can you see my presentation?
Yes.
Great. So I think we kind of agree that the other bit is already done. So my mission impossible that became possible at some point of my life is to make education inclusive by finding a conjunction between humanities and technologies. And everything started at the University of Roma Tre in Rome, as the word suggests already. So at some point of my academic career, I won a bursary for an Erasmus placement in London. So at some point, I got this wonderful news that I was going to London. And I started an internship at the London Metropolitan University, where I started doing this research project about applications for mobile learning. So the idea was to include mobile application to enhance and improve learning. So these are pictures taken from this research project that we did at Ravensbourne University. So the idea was to bring mobile technologies to make the first day of school, the first day of college, very engaging and different from hours and hours of lectures given by tutors or teachers at the university. It was a huge success. So I spent my it was like 4 months in London. It was the most amazing experience I've ever had, although it was my first time abroad. And so obviously I was freaking out, as the first image on the left-hand side suggests. But London was like, I consider it my second home. So I've met so many wonderful people there. And I must say that it was like a mind-blowing experience. So when I finished my internship at London Metropolitan University, I came back to Rome because I was living in Rome back then. And I attended as a visitor the first Maker Faire in Rome in 2013. And I was so excited about this new maker movement, all the things that came with innovation and Arduino and everything. I was like so mind blown that I decided to write my dissertation about makers and the way that they could change the approach of learning, and also the way that they can bring like STEM and technologies also in a creative way. So I presented my dissertation, and during my thesis dissertation, I mentioned Arduino something like 26 times. So probably it was already in the stars that I was going to end up here. And then after my dissertation, I got a job offer at Ravensbourne University College. I don't know what it is right now, but it was a university in London, in North Greenwich, next to the O2 Arena, where I was support engineer for learning innovation. So I was helping out academic staff, so teachers, tutors, everyone, to use technologies and to bring for example, Moodle or e-learning technologies within their curriculum and help them like integrating them in their lesson plans. At the same time, I attended once again the Maker Faire in Rome, but this time I wasn't just a simple attendee, I was also giving workshops. And this is my, like the one on the right, it's myself running this workshop using Little Bits. So at that time, I worked on a small bit that was able to sense capacitive inputs. So I was using both the conductive paint and also the Little Bits to make like interactive and wearable clothing that was some kind of engaging, and it was reacting to children touching them. So it was a huge success and kids loved it. And so I brought my workshop in many parts of the world, in Fab 10 Barcelona, Maker Faire Paris, Somerset House, and also Maker Faire Bay Area. And of course, I think that all these experience with kids, families, people that were interested in technologies and bringing those new tools within their curriculum changed my life completely. So that's why I use this aphorism by Lord Tennyson about, like, I'm a part of all I have met. I think that these experiences shaped my future in a way that I couldn't even imagine before. And so at some point of my life, I was a co-founder of a startup called Makerini in London, where we were designing a lot of activities and after-school clubs for kids. Then it was the time where I joined the Arduino family. It happened. And this picture, once again, is taken at Maker Faire. I think it was like 2 years ago. And I'm really grateful that the Maker Faire exists, because literally it changed my life. And it shaped the way that I conceive my work. I've met a lot of people, so I think that it's great that I was able to be part of this amazing community. And then a few years later, a dream came true because I got in touch with Google and we co-developed together a kit called the Science Kit that was using this technology app called the Science Journal that is still available online on the Google Play Store and also on the App Store for iOS. And it's an app that allows you to basically sense the surroundings around you, and it allows you to get real data in real time from your phone or smartphone or tablet, sorry. So the idea is that you can get data in real time, and you can make calculation, you can make data analysis, you can make data logging. Everything that was, for example, in the past, it was just for like heavy equipment that were particularly expensive. So when I realized that there was this app, it was natural to think about the idea of creating a kit that was able to bring the hardware that was more affordable than the usual like data loggers that you can find on the market, and use something that kids use in their daily lives, like a smartphone or a tablet, and combine them together in order to have like a more approachable experience and also more affordable one. So this is how the Arduino Science Kit was born. So the idea was to bring something that most people knew already. For example, Arduino is already used by university all over the world to make measurements and calculation about, for example, with the sensors that you can attach to the board. So we created this kit. Let me just turn on the
So many things that you can do with it, and it's all put into one. I love how they put science and fun together. There's loads of experiments that you can do. You can also kind of like work it out. Yeah, so you discovered it yourself, so it was really fun doing that.
I see this as a far more gender inclusive product. It's certainly not just for boys. I really like to push that notion that everybody's equal in my room. This kit makes it much more accessible for people to do practical physics. This could lead us into a new generation of new engineers, new inventors, and maybe, you know, diversify the field.
The idea was to create something that was easy for kids to use. It was to be like child-friendly, very easy to assemble, no coding required. So we came with this idea of creating this kit that is completely different from the kind of kits that we usually use with Arduino, because it's already made and it's there and you can just plug it and start playing. So all across my professional career, I tried to use technologies and humanities as a way of connecting people together and let them improve their knowledge in a hands-on way. Because, for example, I wasn't very good enough with physics when I was at school. So for me, it was like a way of getting some kind of revenge on the way that I could have learned back in the days when I was at school. So my mission every day is to use technology and education as a way of improve people and kids' future. And I would like to leave you with this quote by Malcolm X, which is, "Education is the passport to the future, for tomorrow belongs to those who prepare it for today." And in my work, I try to do my best to prepare the next generation of inventors, scientists, technologists, to get the most out of everything they do in their lives. And so I would like to thank you all for joining me. But one last bit. So since this is like a very difficult moment where everyone is trying and struggling to get remote learning resources online, with Arduino Education, we're trying to help parents, children, and also teachers with a series of tutorials, Q&A session, homeschooling guides, digital tools, but most importantly, every Thursday at 4 p.m. We have this, sorry, I can hear my audio in the background. Okay. I can still hear myself. Very weird. Okay, no worries. So every Thursday at 4 p.m. We have a live session with our education expert, and you can join us on YouTube as well. You can find more information on arduino.cc/remote learning. So you can join us with the other tools and other resources that we're publishing online, or join our video on Thursday. And that's it. Oops.
Awesome. Thank you so much, Valentina. That was
Thank
amazing. You. As I said, I'm a huge fan of your work. As someone who's kind of, fell backwards and is starting into STEM education with younger audiences, I'm just now, I feel like, scratching the surface of this space. So seeing the work that you've done and how well you've managed to actually scale up your efforts, and how, you've really made and packaged things that are accessible and more inclusive is super exciting to see, and very inspirational from my point of view. So thank you so much for sharing all of that. And it's funny, you actually started to touch on, I had a question, but I feel like you basically kind of already answered it, which was, is your experience as a kid or as a young adult, like, did you see any glimpses of what you were going to do in the future? And I mean, you mentioned it a little bit about, your struggle with some of the subjects, maybe. So maybe it's a reversed, instead of something that you could have foreseen. But I would love to hear more about what were you into as a kid, or.
Well, actually, it was a combination of both, because, well, for sure there were some technical difficulties when I was a kid, because, for example, scientific subjects weren't really my cup of tea. I really enjoyed math, but everything else than math, it wasn't my cup of tea, basically. So the thing that I was like lacking of was the first-hand experience and the fact that everything was too abstract. So for me, it was like, okay, well, how can I understand better this topic if I don't understand why we're studying it or the way it works? So for example, for the science kit, I decided to give a theme to the kit that is like amusement park rides. So for example, a kid probably don't know that all the roller coasters and wherever, they work with principles of physics behind it. So the idea of combining something real and something engaging and exciting with something very abstract that could be very complicated to understand was the full reason why, for example, I worked on the science kit. More broadly, the reason why I started working in the field, it was that since I was a kid, I was working with technologies. I really enjoyed them, but I realized that a lot of people were struggling understanding technology per se, like using the computer back in days. Of course, now it's a little bit different, but of course, when I was a kid, for example, my grandparents or my friends didn't even have a computer in their homes. So the idea of like bringing them in something that was incredibly useful and very powerful for me was like the real motive that got me kept me going in a way. So right now I really enjoy what I'm doing because sometimes it doesn't feel like work. It feels more like play. Which is also an advantage of like testing out the new kit or the new software. Of course, there is like something that I still enjoy doing. But the reason is that I would like to provide people with like some kind of basic digital literacy. So everyone can speak the same language in a way, but without forgetting the important human factor, because we don't have to forget that behind technology, there is always a human being. So, well, maybe not in the day that we live right now with machine learning and so on, but the idea, well, you get the idea. I mean,
although there's always, there's still a human being, right, behind all those algorithms. And it's funny because in one of my kids' classes, I was just kind of explaining to them how, there is always a person behind all of this technology. Which actually leads me to another question. And you sort of started to talk about, testing with kids and if someone wants to work with, K through 12 or children in general and ed technologies, like, for example, every year I have some students in my classes who are very interested in this topic. How do you kind of recommend them getting started? Because I feel like I'm very lucky to have kids that I can experiment on, but I don't recommend having children just so that you can, use them as guinea pigs. So do you have any recommendations for anyone who's interested in kind of getting into that space?
Well, for example, something that I find it very interesting, and also from the kind of experience that I've seen online from teachers, especially, for example, in Italy, where people don't have necessarily access to computers or laptops. The idea of working around, for example, the way that you can build an algorithm can be like a very good way of getting started. So like following simple instructions, so step by step, okay, step 1, step 2, the kind of correlation that you can get within the different instructions. So you can get started with something very simple, even like analog, if you like, and then you can build up on that. So, for example, there is this wonderful concept by Seymour Papert and Mitch Resnick about the low floor, high ceiling, and wide walls. The idea that you have like a low floor, so you can get started very easily with simple things, but then you can scale up and reach up to the high ceilings. And white walls, because like you don't have one pre-made solution, but you can experience and experiment, especially with different ways of conceiving the solution that you want to build. So this is my recommendation.
Super interesting.
So thank you very much. Massimo, you're on mute.
Mute, it's true. Yes, sorry, I jumped in because so thank you. The presentation, I followed this project since the beginning. I think it's great. Actually, one of the very interesting things that I happened to me recently is I heard a number of people say, yeah, okay, they sent all the kids home to do remote learning, and then a lot of times they don't have computers. So in a lot of countries, and we're talking about developed countries, people don't have computers, so everything you can do with a smartphone is something that a lot of young kids can do. So I think that's a great concept. Thank you, Valentina.
Okay, thank you very much,
Valentina.
So we're gonna put you in the green room where there are free snacks and non-alcoholic drinks, and actually I changed my background to this picture, which the next guest will recognize. So this show, the computer program, in the early 80s was a show on the BBC that basically was teaching people how to use computers and how to program. And the way they were teaching this is using a piece of technology that Dominic is going to tell us about.
Hey, how's it going? Thank you very much. I got a drink. It's only like midday here, so this is ginger ale. I'll be putting a little in there later,
So Dominic, tell us very briefly where you come. I mean, your voice already tells us which country you're coming from, but
yeah,
tell us a little bit about yourself, a little bit of background.
Yeah, so I grew up in the UK. My parents grew up in the UK. My great-grandfather was a Polish military officer and went to the UK during World War II. Hence, I have a Polish last name. But I'm not very good at speaking Polish, so please don't test me on that. But growing up in the UK in the 80s, the schools all had this BBC Micro in the classrooms. Well, I say the classrooms. I remember in our elementary school, we had one for the whole school on a trolley that got wheeled around to each class, as required. And I was a little geek, so I helped out the teacher with getting the discs loaded on this thing. Long story short, me and a whole load of other people in that generation in the UK got their first taste of computers through this program. And I mean, it's really interesting to me because the 80s is the whole home computer boom in general. Like computers went from being things that are in universities or laboratories to these machines that were in people's houses. And really, the kids of that generation were the first people to really get to grips with this stuff without preconception. So I thought it was a very cool time to interact with this technology.
And then you got a PhD in computer engineering.
Yeah, let's skip a little bit. I mean, I wheeled the trolley around the elementary school several years past. I was like writing little basic programs on my. Actually, we had the Acorn Electron at home. The BBC Micro was at school. We couldn't. Oh, there it is. Yeah, there it is. So if someone sends a tweet to that thing, in theory, it should appear there. Don't put anything rude. Don't make
it put it full screen for a second.
Yeah.
So we don't want to steal from your. I just wanted to, say that. Now it's to me, So both me and Dom are huge into this retro computing. We like the history of computers. Actually, Dom, you made a Kickstarter with cars. No?
Yeah, I got slides about. I actually have a slide deck prepared.
Then where is this slide deck?
I don't know. It's in the. Do I have to press something?
I'll remove the BBC Micro, otherwise it's going to get jealous.
Yeah.
And then I'm going to add the slides. Boom.
Oh, wow, you can do that. Yeah, so what happens if I go full screen, it all breaks. So I apologize that you get to see the spoilers of this presentation. Yeah, so I went from the BBC Micro with this, 6502, I was doing basic, to getting a bigger BBC Micro, which had an ARM in there, ARM processor, so I was doing ARM assembler. And then, yeah, when I went to university, that was a kind of later path, but I had this access when I was younger. And this is why, for me, you know, this whole democratization of compute, enabling people to experiment, have low cost, easy access to technology is so important. Because if I didn't have this, you know, opportunity at school, then I just wouldn't have the career I have. And it's quite clear that making this a possibility for everyone is a really key thing. Anyway, sorry, I was talking about Kickstarter cards, wasn't I? So anyway, I'll try and follow a chronological order here, Massimo. Is that all right?
Yeah, please go ahead. Do.
Yeah, we got a new baby. Very much. My brain is, you know, I'm drinking ginger ale. Things could get messy. So anyway, so yeah, I joined Darwin, actually ended up working in the product group for Cortex-M microcontrollers. And so I was product manager for M0, worked on M0 Plus. I did some stuff around positioning this new family. It was weird, when we started doing this was almost 10 years ago, there weren't very many of these things in the world, and now there's, you know, tens of billions of them. It's kind of crazy to imagine. But one of the places it wound up was in the Arduino, and I kind of fell in love with Arduino and you know, and the mission that it has and the ability it has to reduce the boundaries to people to actually get to grips with this technology. But the one thing I didn't do is have any experience in consumer, you know, I had a load of B2B experience, but I'd never done any consumer marketing or did products that went directly to people as opposed to businesses, I guess, if that makes any sense. And so as a little bit of a side project, I made these, like, you know, Trump-like game, as we would say in the UK. I guess in the US, you would just say collectible cards because Trump has a different meaning. But and so, yeah, I put them on Kickstarter and people like those cards. Yeah, that's the story. I'm trying to stop myself rambling. You got to cough if I do.
You do whatever. You're introducing yourself. We are basically listening to you.
Yeah, sure. I mean, so here's the thing I noticed, and that is, actually, Massimo, we were talking about this before, this idea of, like, you know, nostalgia is a powerful force, especially in moments where, you know, things are kind of stressful in the wider world. And so falling back to familiar, comfortable things is definitely something which is happening more, I think, within the confines of people's homes. But also for me, it's like, if I wanted to get to learn a little bit about, you know, the web audio API, I do this little project with the audio cassette, or Kickstarter and consumer products, I did a little thing with the cards, you know. It's almost like, to learn something new, I used retrocomputing as a vehicle for that. And in technology, there's always something new to learn. I mean, it keeps on moving, right? It's impossible to know everything about this stuff.
Yeah, so basically, just to give us some background, the tape on the left is basically a software that simulates a cassette tape player, so you can load programs into old computers.
Yeah, exactly. So you can, like, load it up. It's like a web app that runs on your cell phone, and on the fly, it will, I guess you say, modulate the program data into audio using the web audio API, and then stream it out. So you can, like, you know, that kind of beep, kind of 80s computer cassette noise.
Yeah, to me, I've always seen some parallels between, in a way, Arduino and the computers that we had when I was a child in the 80s.
Yeah, totally.
Because you would put them out of the box, you would turn them on, and then BASIC would show up, and you would just start typing, and then you had to learn how to program. There wasn't a lot of, you know, stuff that you came just pre-made, so you had to, you know, learn how to program. And so in a way, this idea that you learn how to build your own software, and it's funny because, you know, the BBC Micro was very influential because it was in the schools and everything else. And so I lived in London for 3 years, and a lot of the geeks I work with in London had learned on a BBC Micro or a ZX Spectrum. And so these machines kind of created a whole generation of computer scientists.
Yeah, exactly. And so on the theme of, like, random retro projects, I also did this thing called the BBC Microbot. So the idea behind this thing, and this is partly because, you know, I got some old retro equipment here, but actually not much room in the house anymore. because we have a new baby, and so that stuff's been packed away, or was. I managed to retrieve a little bit. But I wanted to create something that allowed a really easy interface to have a bit of retro computing, make a bite-sized thing. So you write a tweet and it will run it on a retro computer and post back a video of this thing. And it got kind of popular. I was very surprised. So we had Ben Goldacre tweeted about it. He's a very famous science writer in the UK. And then Eben Upton, the founder of Raspberry Pi, did some very cool implementation of Conway's Life. He did some really fancy trickery by using a base 64 encoder, putting some machine code in there, and then bootstrapping it with BASIC. It was kind of impressive to see. In fact, the things that people are doing with this microbot now are far better than what I had planned with it. So that's nice. It's like a little platform in its own right. But it just shows to show there's so many people there that they have a lot of affection for that first experience with computing, a lot of an emotional bond, in fact, with that that time and with those pieces of equipment, which is interesting in its own right.
Actually, I have a quick question for Benedetta. Which was your first computer?
I was trying to, that's exactly what I wanted to Google it, but I didn't when I get distracted. I'm trying to think if in school we did something, and I feel like it was Logo, maybe, was like the first programming language we were introduced. I remember the little triangle turtle and the degrees. And so that was my introduction to, I think the course was called informatics or something like that. And so whatever machine that ran on was the first computer I've ever had. And then I'm trying to think, I don't remember the machine itself. I just remember the old 1980s printers with the collated paper with the holes on the side. And I was just typing. I didn't even do programming other than what I was introduced in school. But maybe it was Logo, right? Is that what that was?
Yeah,
pure.
Like forward 100, right 90, and all that kind of stuff. Yeah.
Yeah. And then in middle school, we did Pascal.
Which is great.
Pascal, my first year of uni. Anyway.
Yeah, it was a very strange experience.
That was the last time I ever used it.
I will date myself by saying that I learned how to program in Pascal with UCSD Pascal on an Apple II. But the Apple II was very old. It was very, very used. So it wasn't. I didn't learn in the 70s. I was not old enough to press the buttons on the keyboard. But yeah, so my first computer was the ZX81.
Oh, nice.
Just since we are here, actually, if you are following, I hope you are following, please write in the chat next to this video which one was your first computer. We want to know. Yes, nerd alert, but I don't care because we're a bunch of nerds here.
Also, I mean, did I mention there's like a BBC Micro in the corner of this garage rigged up to Twitter? Send a tweet to that and it will run it. And we'll put it up here.
Yeah, let's try an experiment. I'll add the BBC Micro here, but so you can see
it's thinking. Well, actually, that's the last tweet it received, which was me. It's kind of boring. It could do a lot more than that.
Anyway, so you recently built another project that combines Arduino and the BBC Micro because you wanted to.
Oh yeah, exactly. So the BBC Microbot was using an emulator. In fact, it was emulated on a Raspberry Pi in my garage. But I had to bring this project to a conclusion, and so I used the Arduino Nano Every. And actually, on the BBC, there's a keyboard connector, like a row of pins, and the Nano Every, it just fits really nicely. I've not got autofocus on this thing. I'm sorry, but anyway, with one row of headers, you can just slot it on really nicely, and then the Nano Every can type on this machine. And so now, if you send a tweet to this account, the Raspberry Pi will retrieve it using the Twitter API.
Somebody typing.
Yep.
And then type it on the machine. It's typing now. Wow.
Somebody's sending some hardcore geometrical stuff.
Yeah, this is actually, yeah, this is, Paul, I think.
It's Paul, it's...
Is it going to work?
Yes, it's growing. OMG, live demo. Live demo.
This is going to, we have to give it a bit of time here, because what happens is
let's put it
these
back.
machines are super slow, and so they're going to render in multiple colors, and then it's going to cycle the palette to make it look like it's moving. So you have like red, green, and blue, and then you turn all of them black, and one of them is white. There you go. It worked.
It's let me bring it back to full screen. Wow, it's even rotating.
Yeah.
Holy sugar. Wow.
Very nice.
Boom. Congratulations, Paul. Perfect timing. Yeah, so just to touch a little bit on what you just said, just for the people who don't know, the Arduino Nano Every is the latest member of the 8-bit Arduino Nano family. It's very inexpensive, it's something like $9, but it runs a much faster processor than the current Arduino Nano clone that everybody uses. So it's got more memory, it's got more RAM, more flash, more peripherals. It has actually, so it's actually a fairly sophisticated 8-bit processor, and it's faster than the regular 8-bit Nano. So yeah, I mean, so you use that to basically simulate the keyboard.
Yeah, exactly. And actually, the BBC Micro design is a very clever one, and it does some pretty fancy stuff. So the keyboard doesn't send any key presses; it just sends one interrupt, and then the BBC Micro has a counter, and it scans all the columns and rows of the keyboard, and the Nano Every has to respond back just in time, saying, "Yeah, that's my key." And so the timing has to be very, very tight. And actually, I got to tell you, normally I'm a 32-bit microcontroller man, as you know, but this guy did the job in this particular case.
Nice. Yeah, no, I love this. I love this project.
Yeah, so these are people tweeting live at the account, and it's appearing live on YouTube. I don't even know if they know it's there.
So I was joking a few days ago, and I said that you and I, Dom, should get our own retrocomputing show on streaming. If anybody here would like to have an Arduino retrocomputing show live, please write it in the stream, and then me and Dom will think about it. So yeah, so in the last few minutes that we have left, do you want to talk a little bit about what you're actually doing right now that's not retro computing? Oh,
yeah. Give me a second here. I just I went offline. My camera's gone off. Wow.
I like
That's exciting. You can still hear me though, right?
Yeah, we can still hear you.
Well, you know, we're looking at a slideshow anyhow. Let's tolerate that for a minute.
I'm looking at some guy is trying to crash your BBC Micro.
It's right.
It's pitting out an hexadecimal dump.
The nice thing about using the keyboard interface is it's directly, the break key is wired to reset. And so you can totally reset the machine. Yeah, on the machine learning stuff, we did some really exciting stuff with Google late last year. And we have the Arduino TensorFlow Lite library with a bunch of examples where you can actually get machine learning or neural network-based machine learning running on your Nano BLE Sense. And the BLE Sense is a really nice little board because it's got a microphone, it's got accelerometer, gyro, magnetometer, it has also a color sensor, a load of cool things that you can use to do voice detection or gesture detection, all this kind of stuff. And we had a really big response to this, the tutorials and the material we put out around that. But I think, you know, we were talking about this, Massimo, and we still have more to do in this. And in some ways, you know, machine learning doesn't have to necessarily mean neural networks. And maybe we went straight to the top there where we have a little bit of a journey we can start to take people through. And so that's some of the stuff we're planning to do in the next few weeks. Was that the stuff you wanted to hear about?
Yeah, no, I was because just because we talked about the 8-bit stuff, it's nice to also kind of highlight a little bit some of the work that you have been.
Oh yeah, this is the stuff I'm doing at 3 or 4 in the morning when the baby's, eating.
So if anybody is interested in doing machine learning on small devices, this Nano BLE Sense, I think it's a great platform. Again, it's not too expensive. It's like $30, but it's got a ton of sensor. It's got probably one of the best Bluetooth radios on the market. It's running Embed OS, so if you're using the Arduino language, but if you want, you can call the operating system, and then suddenly you have access to a real-time multitasking operating system. You have a gazillion sensors. So in a way, I think it's a very interesting device. And we work with the team at Google TensorFlow, so you can run TensorFlow like Micro on it. But there's some other work that we did, that Dom has worked on, to actually create libraries that are more simpler to use. Not simpler to use, but I'm saying you can actually use older algorithms that are simpler than what TensorFlow does, and you can still get some reasonably good results. So I think it's going to be an interesting, there's going to be more interesting stuff coming out.
Yeah, and actually, I mean, we're talking with some industry experts and some interesting startups and all kinds of cool people in the machine learning space that we hopefully can come say hello on Bar Arduino at some point.
Yeah, totally. So keep an eye on this Nano BLE Sense and also on the Nano Every. If you're doing projects with 5 volts, but you want more memory, more power, and you want something super inexpensive, the Nano BLE, the Nano Every is perfect. It's running the latest Mega AVR cores from Microchip, while this board here, the Nano 33 BLE Sense, it's running a Cortex M4 from Nordic. So it's a pretty nice device with a lot of stuff on it. And actually, at the end of the show, we are going to ask Valentina to tell us a little bit. She's doing something. We don't want to spoil but she's doing something with the Nano BLE Sense. So I want her to maybe mention it at the end. Right. So So people seem to be enjoying playing with your thing now. People here have learned with Acorn Electron, but they wanted the BBC, ZX81, but it sucked. What do you mean it sucked? I love it. It was fantastic. It was fantastic. You don't understand. I learned how to program on that machine. Almost.
You've seen Micromen, right, Massimo?
Oh yeah, that was fantastic. If you are into retrocomputing, dig out this show from the BBC called Microman, which shows the history of how Acorn and Sinclair started off and how the BBC Micro, Spectrum, ZX81, ZX80, it's all in there.
I remember when we went to Cambridge once, you insisted on going to the Baron of Beef and just so you could say you'd been there.
Yeah, there is one scene where, in that pub, there is a scene where Clive Sinclair punches Chris Curry, I think.
Oh no, actually, I can't remember.
So the lady behind the counter who's kind of, selling the beers, actually, it's a cameo. That's Sophie Wilson. That's the person who designed, along with, I guess, Steve Ferber, they designed the ARM processor.
Yes, so, I think Sophie Wilson did the architecture and Steve Ferber the implementation. Also, yeah. Sophie Wilson developed BBC Basic, which this bot is running. Anyway, I won't go on about. We can do the
huge fan of Sophie Wilson. I saw her once in the streets of Cambridge, and I was like, oh my God, how am I gonna say to her? So I just, I stayed silent as a sign of respect. Okay, so thank you very much. I will send you and your devices back to the green room for a second, and we'll bring you back at the end. All right, so Oof, I like this stuff. Sorry, I've been talking too much.
No, now I'm gonna have to like go and make some calls and trying to find the answer to your question.
Really?
I feel like I didn't answer. I only knew the programming language, but it didn't. I still don't know a machine that was. So I feel very ignorant right now.
It's fine. It's fine. But you are, you're younger than me. So when you were a kid, probably it was more like a PC world, and the PC were kind of all the same in a way. It was hard kind of remember the specific PC.
Yeah, anyway. My computer was a hand-me-down, so it was definitely. But the school ones, I feel like, must have been, it was the early '80s. So.
All right. Okay. So I'm going to bring the next guest, and then I'm gonna remove myself from the screen. Welcome, Pascal.
Hello. Good evening.
Benedetta, I leave you to talk to our guest, and I'll see you in a bit.
Yes, we have Pascal here, who's an engineer calling us from Belgium, very passionate maker who's been working on some really interesting projects and has been wrapping up some projects, starting up new projects. And so we would love to hear more about what's on your workbench right now.
Okay, thank you, Benedetta, for inviting me on the show. I saw some people in the audience from Shanghai, Peru, Brazil. I think I've never spoken to an international audience like this before, so really exciting. Yes, you're right. My talk is going to be also a bit more technical, so I brought the stronger beer. It's a Cornet, and I'll bring it in the slide deck later on. I know the people from Italy have good wine, but in Belgium we have excellent beers, so cheers. Okay, I'll be briefly, because I just have 10 minutes, discussing 3 projects of the long stack of projects that probably you also have. And it's one that I've done recently. Let me switch to the slides. Here's the beer. And this is a project that I've built for an application for a friend of mine, and it's an NFC reader. What's so special about it is that probably many of you have built a batch reader or a card reader with NFC, but that technology has changed a lot in the recent years. Smartphones have NFC capabilities and so on. And so there's many standards. And at a certain moment in time, NXP, the manufacturer, decided to make sort of a next generation NFC chip, which would cover all the standards and all the cards that there are. And this chip has the name PN7150. So it's like the flagship of NFC. And apparently, when we wanted to use this chip, there was no open source drivers for that available at all. So I started to investigate it, how it works. And it has a Cortex M0 inside the NFC reader, which means like you're basically talking to another processor on a higher language. And so we managed to get it working. Not everything that can be done with NFC is in this driver, but it's doing pretty well, and it's on GitHub, so anyone can take a look there if you have an NFC project on your stack or in the near future. Maybe interesting to mention is that what you see on the right-hand side is the batch reader that has this application inside, and this is a project from a friend of mine, David, who is building a Fab Lab management platform. So whenever you have all this equipment in Fab Labs, maker spaces, there's the question, who is entitled to use which machine and who has been using it the last time and for how long, etc. And so what he has built is this small black device. Basically, when you start using the machine, this one's a 3D printer, you just swipe your badge. It welcomes you. You're entitled to use a 3D printer. Go ahead, and it measures the amount of time that you're using it, and so on. And this all goes in a big database, so we know better who is using what machine inside the makerspace. I thought it was an interesting project to mention that. Okay, on to the next one. That's the one I'm currently working on, and I've given it a name. It's SmartTherm, but I think this is a nice example of how quickly you can develop nice applications with everything that's standard available in Arduino. I had this Junkers Bosch central heating in one of my apartments, and it's not very old, but it's too old to have a smart regulator on it. So it's just basically switching on off. And I found out that in fact this device can be used in a much more efficient way if you gradually control out what they call modulating. So you don't give a 0 or 100% of power, but you control the power somewhere between 30 and 70%, and then it's much more efficient. And apparently there's many people that have this problem or question on the internet. So I started to investigate this as well. And I put some nice standard libraries together. That means a thing like, I don't know if you heard of it, the Blink smartphone library. It basically allows to make a smartphone companion app in like 5 minutes. I've linked in the over-the-air updates, which means you don't have to plug in any USB cable or whatsoever. You just sit with your laptop next to the device and you reprogram it. I think that's fantastic as well. And I also used a touch screen in this one. Now, doing a touch screen is, it looks simple, but it's really hard stuff because you have to deal with fonts and images and all that stuff. But then I found this Nextion touchscreen, which is a Chinese company, and it's really cheap, like 20 euros, $20, and it allows you to take all these standard components, and for under €100, you build a very nice controller. Again, I put everything on GitHub if people are interested to control their Junkers Bosch with this. They can do so. I've currently running it on an ESP8266, but it's just it can be on any device which has Wi-Fi, like the Maker 1000, for example. Okay.
I love how practical these projects are and how useful.
Yeah, it's well. I think that's the joy of making something yourself, is that you get to much more appreciate the device and working with the device because you've made it yourself. So some people say, if you can buy it, why should you make it? And I always turn it around and I say, if you can make it, why should you buy it? It's much more fun to make it. Okay, going to number 3. It's more kind of a long-term project that I'm working on. I given it the name Moovr, and basically I have a prototype here. It's on the slides, but so it's rather big machine. What is the idea here is that one of my hobbies is also 3D printing and CNC production, and most of the do-it-yourself hobby CNCs, they are running a software which is called Grbl, GRBL. And this runs on an Arduino. But the thing is that this Grbl, even though it's fantastic, it's really at the limit of what the Arduino can do. There's the 32 kilobytes of ROM, and 2 kilobytes of RAM is really completely full. So it's at the end of its possibilities. And I think there is maybe some room for a next generation thing here. And recently, lots of very powerful 32-bit devices became available. What you can see in the picture here on the right-hand side is a Teensy 3.6. It's not made by Arduino, but it's completely compatible with the Arduino ecosystem, and it's also like 20 euros, so it's really affordable. And what I'm doing here is building on this platform, trying to make a 32-bit motion controller. So it will be able to control a CNC, a laser cutter, a 3D printer, a robot, whatever you want. It will have at least up to 6 axes can be controlled. Lots of sensors go in there. One thing that's worth mentioning is also that on the older 8-bit controllers, you had to do everything in integer math because they didn't have floating point capabilities. But this new generation, like the Teensy 3.6 or the Arduino Portenta and so on, they have floating point built into hardware. So now we can make much more accurate calculations. We don't have to do simulation of doing floating point calculations in integer. We can do it in floating point right away. And so the project here, it's also on GitHub. It's not functional yet because I'm still working on it, and it's sort of on the back burner. But it intends to be a really good motion controller that I hope will pop up in CNC machines and laser cutters in one of the next years. Okay. That's my projects. I also brought a question to the community. Actually, I think maybe it's good if Massimo joins in. But since I have the stage, I think is an interesting thing to discuss is if we could have on the Arduino ecosystem something like what they call the SPIFs, the SPI file system that we have on the ESP ecosystem. I think it's really useful because what it means is that the microcontroller has, like, for example, 4 megabytes of flash memory, and you can split it up into code and into data. And you can put things like configuration files, log files, audio files, image files, whatever. They can easily go in this file partition, let's say. And so you don't need to have an SD card or do other weird things. I think it has been very handy to have this feature on the ESP system. I'm missing it on the Arduino ecosystem. So with this, please vote in the YouTube chat if you like this feature, and if there's lots of votes, I'm sure that that Massimo will try his best. Okay, that's it. Thank you.
That's amazing. I like the plug. Thank you so much. These are awesome. As I mentioned, I think that, like, you know, the practical nature of these projects and the fact that they're addressing like real issues. I was looking at, you know, the NFC project. I mean, I feel like I've run into so many different shared spaces where the tracking and the management of like assets and usage, it's always been kind of, you know, if you figure that out, then it's like the holy grail of logistics in maker spaces and things like that. And
absolutely.
Even the thermostat, I mean, I love your philosophy of like, if you can make it, why buy it? I mean, you get to not only learn about it, but you made something that's a lot better and it works a lot better, and you know exactly what capabilities, you know, now those devices actually have. Has there been like I don't know, maybe with the Moovr project or one of the recent projects you've been working on, like a haha moment that you had that you feel like other people should know about, or some very kind of, I don't know, some lesson learned from one of the most recent projects?
Yeah, with the NFC, there is one thing. Well, it's not a aha moment, but it's in the very back in my older days when, I mean, I was manufactured in 1966, so that was before the Arduino and so on. Getting data sheets was collecting big pile of books, and we didn't have Google and we didn't have all that stuff. And then there was a time when it became all more and more accessible. So now today it's easy. If you need a data sheet, you just Google. But with the NFC project, I found that the NFC forum, who is making the standards, is going back away from that. And the standards are no longer public available, and you have to buy them. And they're very expensive for a hobbyist maker. So I thought that was a sad experience to see that after technology becoming more open and open and open over the past few years, I'm now sort of worried that it's getting more and more closed again. I don't know, maybe they want to make more money or they want to get more market share. I don't know why they do it. I think the more open, I think the better, but apparently not everyone thinks this way.
Do you have any like recommendations for somebody who's really getting started with IoT devices, like the ones that you've been working on?
I would say best is to take your turn to YouTube and look for a project there, because when I started with I'm also of the older generation, so I like to read stuff in books, and I've bought a couple of books on IoT, and they were all very disappointing, because it's kind of a hype, and then the book company says, okay, maybe we should write a book on IoT. Who can write a book on IoT? Okay, let's take an existing book and we replace a few words with IoT, and it's a book on IoT. So books are not the best source at this time. So I would say go to YouTube, and there's lots of people that are doing interesting and small projects, building stuff there. And of course, yeah, all the examples that come with the different Arduino libraries are also a very good place to start. You can almost always load the library, run some examples, and start from there.
So if I can jump in, I would recommend that everybody try out the Arduino IoT Cloud, because you can find it at create.arduino.cc. I think one of the interesting things about the IoT Cloud, if I can plug this for a second, is the fact that we tried to design it with this mindset that was at the base of Arduino originally. So the idea that a lot of the boilerplate should kind of be solved for you. So for example, in the Arduino IoT Cloud, you define the properties that your device has, and basically all the code gets generated for you. And then you just have to basically read the sensors and basically say, hey, send this data to and that's it. And then it generates automatically a dashboard for you, and then you get APIs you can talk to from. So, if somebody wants to try IoT, I would recommend they play with the Arduino IoT Cloud, which is free up to a certain amount of device, and then there's a plan for more devices, or it even supports ESP8266 in the paid version. In the free version supports Arduino devices.
Of course.
And obviously all the different bits and pieces, somebody says open source is the better. Well,
talking back to the retrocomputing, do you recognize this one? This is the retro calculator.
Oh boy, that's an HP calculator. Wow, cool.
Still using it.
Very nice. Wow, so thank you, Pascal. This is great. People in the comments loved your projects, and so I put some of them on the screen. Actually, I have to put the banner that reminds people how to participate, because you participated by sending an email.
Yes.
Thank you.
And we love this, because we like the fact that we just want to get people from the Arduino community to say, hey, I want to talk about what I do, boom. And then we invite them. So you had all your contacts at the end of your presentation, so people can now find you. Let me bring back the other guests, because you saw the icon last round. So now we are basically like in every respectable pub, we now have to have the last drink, and then we have to say goodbye. So, well, thank you very much to all the guests. So now it's time for you to plug, projects, URLs, social media. Let's start with Valentina.
Okay, I wasn't expecting this. So I want to thank you all for joining the streaming today. You can reach us out on arduino.cc or my Twitter at Sorcière Rouge. then I can write it down to the chat, which is easier. And also you can reach us out on all our social media, Twitter, Facebook, LinkedIn, Instagram, whatever you have in mind, we have it most likely. And also don't forget the arduino.cc/remote learning for learning together with us. Even if we are apart, we're together. Thank you.
Cool. So since you're Italian, you get to also say hi to your relatives.
Ciao mamma, ciao papa.
It's okay. It is always, for the Italians, it's always important at this moment that you say hi to your relatives. Dominic, it's your time to plug.
Wow. Thanks for having me, everyone. So I mentioned a little bit about the ML stuff. If you go to arduino.cc/AI, there are some really nice getting started tutorials around the Arduino BLE Sense. Maybe if you have me back, I'll do more of an interesting demo around that stuff next time.
Totally. Pascal?
Yes. Okay, thank you for having me on the show. It was exciting to present to all these people around the world. I saw there was a big fan club in the YouTube comment stream, so that's also nice to see. And I'm looking forward to the next episodes and to learn from other makers around the world on all this fun technology.
Yeah, also I have to say, there was one super sweet moment because your son came in and said, "Hi, Dad," which was like the cutest thing. And so that was a nice moment. One last quick thing, Valentina, are you still doing that webinar on April 26th or no longer?
It's on April 23rd. 23.
So it's like 2 days.
And it's in Italian.
Okay, it's in Italian, but Valentina is doing a webinar in Italian, which is about something new that we are sort of about to announce. So it's going to be a surprise, and it uses
the Arduino Nano 33 BLE Sense.
Nano 33 BLE Sense, coupled with a pretty famous programming language used to learn about the basics of programming. So if you want to learn about it, you got to join this webinar. And
I can add more information in the comment section, so everyone can learn more about that.
Provide all the information. So Benedetta, how did it go?
This was super fun. Thank you so much for joining. It's really nice to, learn from what everybody's working on. I really, really enjoyed our conversations and learning about your projects. And I'm always kind of, thinking in the back of my head how to come up with collaborations with everybody that I meet. So my mind is, my wheels are spinning now. So I'm excited to finally have met some of you, and I love the work that you do. So again, this is like an opportunity to actually put like a real face to a name and to like online documentation. So very exciting.
Well, so thank you very much to all the guests and the people who are watching. I'm going to take a sip of water while we say goodbye to all of you. And thank you very much, and I'll see you next week. Same channel, same time, and good night.
Good night.
Ciao.
Bye.
Bye.